I'll just keep writing down. Did you take the bus or something? Did you take the bus or something?
No, I drove here.
Are your ears itchy?
No.
Why are you shaking?
Apparently, one of my class videos got recommended to a bunch of people. There were a bunch of comments going, why was I recommended this? It's 3 a.m. Why am I here?
I had that problem one time in 6th grade with this college lecture that was an hour long. I was like, oh, it's 11 p.m. What am I doing here? It was interesting though.
But it's that people just randomly clicking on a video whose title is just a string of numbers.
YouTube's recommendation algorithm is weird.
Yeah. And
This.
somebody said, it seems mathy,
Yeah.
so I just gave it a like and got out.
This is your big break. You're famous.
Yeah.
You don't even
And
have to teach.
It's as if they hit like because I'm cruising for likes. Someone once said, you get more views if you give a more descriptive title. And I'm thinking,
Wow, that's
why?
nice. I don't care.
That's not the goal.
All right, any questions? All right, I believe we had just done a projectile motion problem. And I was about to embark on the hardest of the projectile motion problems. So let's do it. If you can handle this, I don't think there's a projectile motion problem I can give you that stuff. If you can't get this, well, I guess you can't get it. Hopefully you can follow this down. So we're going to start this like we have with any of the projectile motion problems. Let's establish a coordinate system. So I'm going to make I hat to the right because that's the direction I drew it in. J hat, I saw a finger pointing to upwards. I hat, J hat. Then what? How do we start the other two projectile motion problems?
Write down what we know.
Say it again.
Write down what we know.
All right. So I've got my I hat side and my J hat side. I have my displacement, initial velocity, final velocity, acceleration, and time. What do we know?
Displacement is 50 meters. J hat,
Sorry, what's the displacement, J hat?
50 meters.
100 meters, you mean?
Wait.
No, wait.
Oh, wait, well, negative 50 meters.
There we go.
I was in the water.
What are we trying to find?
The angle.
The angle.
And then you have 100 meters I have.
Displacement.
What's the displacement? Say again.
100 meters I have.
All right.
Velocity is 40 meters per second.
I have a J hat. 40 meters per second is at some angle.
Acceleration J hat is negative 9.8 meters over second squared.
You're assuming this takes place on Earth, I guess.
Yeah.
Let's go ahead and establish that.
And then the acceleration for I hat is 0 meters per second squared.
All right. Well, that's all that we have very explicitly, the full number for. However, we do need to deal somehow with that initial velocity, which that 40 meters per second is not I hat or J hat. It's a combination of the two. So what do we do?
Do the triangle? Yeah.
Yes. Officially known as break it up into its perpendicular components. So I have a triangle, I have a hypotenuse of 40 meters per second. Breaking it up into horizontal and vertical components, this angle here is theta, that is a right angle. What is this adjacent side here?
15 meters.
2 issues with that. One, the hypotenuse has to be the biggest one. And 2, units would be meters per second. All right, so we got 3 major trig functions, sine, cosine, and tangent. Since I have a hypotenuse, sine or cosine would probably be the better one. Which one is associated with the adjacent?
Cosine.
So this is going to be the hypotenuse times the cosine of theta. And this one,
Hypotenuse times the sine.
without the question mark.
Hypotenuse times the sine of theta.
How would Mr. T say it?
What is that?
Okay, I'm back. Ask your parents, or potentially your grandparents.
How old are you?
I'm 60.
Okay, don't ask my grandparents. They are 100 and
I bet they still know who Mr. T is. Anyway,
my grandpa doesn't know how to work anything, actually. Except stand. He can stand up.
if he watched TV in the 80s.
He did not watch TV in the 80s. He was
Okay, then he does not, potentially does not know. So this is 40 meters per second times the cosine of theta, and this is 40 meters per second times the sine of theta. Just as a side note, does anyone in here know who Mr. T is? All right, thank you. There's one. I remember in the 90s, the first time I made a reference to a record, and I had a student who didn't know what a record was.
oh no.
They knew what a CD was, they didn't know what a record was. It happens. Anyway,
The 90s?
yes.
How don't you know?
All right, so now what?
Is T in this referring to time?
Yes. What did we do before?
Are you asking us to solve?
What did we do when we were solving projectile motion problems before? What did we do?
Find the next thing.
Find time with the third equation.
How do we find the time? I think you made reference to the third equation, but we don't have any third
Yes.
equation written up here. Yeah, what is,
Uh,
the third equation depends on what's written on the board. It's not a universal, if physics students would tell you what the third equation is. So specifically, what equation word are we gonna use? Bueller?
just say it out loud. Oh, displacement equals initial velocity times time plus 1/2 times acceleration times squared.
Tell her about the question mark.
Oh, period.
All right, so we have this equation here, which we have used several times. I mean, you can play around with some of the other ones, but it's gonna eventually come back to this one. All right, so let's plug and chug. Or let's plug and then figure out what we need to do. So I have two separate sets of information there. Let's plug in the I hat, see what we get. So I have 100 equals 40 cosine theta t plus 0. And plugging in the j hat information, I have negative 50 equals 40 sine theta times time plus 1/2 negative 9.8 t squared. I have two equations, two unknowns. This is now, as long as they're independent of each other, it is solvable, and they are independent. So, how would you recommend we solve this?
The first one I had, that is,
Yes?
you just divide by 40 cosine theta. No.
And what are you solving for?
T.
And then what would you do?
Plug it into the same.
Yes. Yeah, it's the same basic process we do in algebra. You solve for an unknown, you stick it into the other one. Now, this is more difficult than the typical algebra problem in the fact that cosine of theta and sine of theta kind of act like in two different variables. Even though it's officially one variable, they act like two because the cosine theta and sine theta are sort of connected. So we actually will need a third equation in order to relate these two things to each other. But first step, let's go ahead and solve for time, and then plug into the second one. Now, because of the amount of writing that's going to happen, I'm going to make an abbreviation here. Instead of cosine, I'm going to write C. Instead of sine, I'm going to write S. I'm going to make the substitution back different at the end, or put it back in the end, or near the end. But it's just a lot of writing, and the more writing I do, the more chances there is I'm going to make a mistake. So I've got, so 100 is equal to 40 CT, and so T is equal to 100 over 40 C, which is 2.5 over C. And again, I should put it out here, though I'm not going to write it on each of these boards. Cosine of theta is equal to C, sine of theta equal to S. Negative 50 is equal to 40 ST plus 1/2 of negative 9.8 is negative 4.9. Minus 4.9 t squared. Make the substitution in here, so I have negative 50 is equal to 40 s 2.5 over c minus 4.9 times 2.5 over c, that fraction squared. Same process as you would for so many things that you've done. Two equations, two unknowns. Simplifying this a little bit, I get negative 50 is equal to 100 sine divided by cosine minus, what's 4.9 times 2.5 squared? Just the 2.5 is squared. It should be somewhere around 30.
30.625.
30.625 divided by c squared. All right, so how do I connect sine and cosine? What is the relationship between the sine of an angle and the cosine of the same angle?
Is sine over cosine equal to 1?
No.
Cosine's.
No, that's
okay,
equal to tangent.
Yeah. Sine divided by cosine is equal to tangent. Well, let's go to our right triangle.
That's just the hypotenuse.
What's just the hypotenuse?
S over C.
It's the slope. Slope of the hypotenuse, if you want. If I call this A, B, and C, I know that A squared plus B squared, and that's a right triangle, equals C squared. Pythagorean theorem. I'm assuming everyone's comfortable with that. If you're not, then we probably should talk afterwards. I know that if this angle here is theta, I know that the cosine of theta is equal to A over C, or A is equal to C cosine of theta. Try that one again. A is equal to C times cosine of theta, which is what we did before when we broke 40 up into its components to get 40 cosine of theta. The other one, B, this is going to be equal to C times the sine of theta. So if I plug into this equation right here, I have C times the cosine of theta squared plus C times the sine of theta squared is equal to C squared. So all I did was take our trig equivalents, plug into Pythagorean theorem. So this becomes C squared cosine squared theta plus C squared sine squared theta is equal to C squared. Every term has a common factor. Yes, Robin?
I'm confused how B over A, which is sine over cosine, is not equal to C if it's rise over run.
The slope of the hypotenuse
And
is tangent. You said before that sine over cosine was the hypotenuse.
because tangent is the hypotenuse, which is the slope.
We are using different words here. Hypotenuse is this line segment right here.
Yes.
It has different aspects to it. There's a length, there's an angle. Well, there's two main aspects of it. When you say the hypotenuse, like people generally are referring to the length.
Is that not a slope?
No,
It has
length
a
is that long. That would be the same length, right? In theory, that's the same length as that is, but that's definitely a different slope.
Oh, okay.
All right. What's the common factor down here?
C
squared.
All right. Divide every term by C squared. And on the right-hand side, we get 1. And on the left-hand side, we get cosine squared theta plus sine squared theta. If you're not familiar with this, you might want to familiarize yourself with it. You take any angle, find the cosine, square it, take the sine of that angle, square it, add them together. You'll get 1. If your calculator does not give you 1, then you potentially have an issue with your calculator. And it doesn't matter if you're in radians, degrees, or radians. You about to ask a question? No. Any questions? All right, so we are now left with this identity here, and that's an important trig identity. The fact that sine squared plus cosine squared equals 1. So over here,
Pythagorean identity, correct?
say it again.
The Pythagorean identity, correct?
I can very well believe it's called that. I don't recall it.
If I took out my math notebook, would you believe me?
I said I could believe it's called that. It's not something I call it, but
Okay.
c squared plus sine squared equals 1. So I can now put them in terms of one in terms of the other. So the question is, do I solve for cosine here and substitute, or do I solve for sine and substitute? Which one feels right? Solve for sine? All right, so from this, I know that sine is equal to the square root of 1 minus cosine squared. We plug that in. We get negative 50 is equal to 100 times the square root of 1 minus cosine squared, all over cosine, minus 30.625 over, that should be 1 minus cosine squared. I now have it in terms of a single entity, the cosine of theta. So now we just need to solve for cosine of theta. And once we solve for cosine of theta, we can solve for theta. We potentially will end up with 8 answers, of which only 2 are correct. But that's okay, we can do it. And I did warn you, this is the hardest of projectile motion problems. Now, how do you solve for a variable? How do we solve for c when I got part of it under a radical?